Okay, Algebra 1 students. So this is the next installment of learning how to solve absolute value equations. At first, we learned about graphing absolute value functions and how to transform them in the plane. Now we're going to look at finding these solutions when y equals a particular number. Okay? So here we have the absolute value of 0. That's this black graph. And our other graph is the constant function y equals 7. And you can see that here are the solutions to this particular problem. And we're going to flip back and forth between pencil and paper and this video so that you can see how to do the algebra while we're looking visually at how to solve these equations by graphing. So let's switch back to pencil and paper and see what this looks like. Okay, so here you have absolute value of x equals 7. Now I'd like you to note that the absolute value portion is completely isolated. There's nothing multiplying it, dividing it, adding or subtracting it, and there's nothing going on. Well, it doesn't matter if there's anything going on the inside. Right now we're looking for other things on the outside. So the minute that you have your absolute value part isolated, you may, in this case, you can just graph it. Okay? So here we have 7, which is the positive side. And then we're also going to have negative 7, which is the opposite side of the number line. Let's add some complexity to this problem. Okay, so here you see that we have added a little bit of complexity. We've kept our constant function y equals 7, and instead of just having the absolute value of x, we're adding a horizontal shift. You see how the graph was over here. Now it's been moved 5 steps to the left. Okay? So here are our visual solutions, -12 and -2. And you can see clearly that here's 0. Okay? This is the distance to 0 from this solution, and here is the distance from 0. So now let's flip over to pencil and paper and look at how to solve this all by ourselves. Okay, so now that we've looked at this visually, let's do it with pencil and paper. So I'm going to solve this one first. So I'm going to subtract 5 from both sides, and look what I got. I got x is equal to 2. Okay? You saw on the visual that one of the solutions was 2 steps away from 0. So now let's go ahead and solve for -7 on the other side of the number line. So let's subtract 5 from both sides and look what we ended up with. We end up with x equals -12, which I also hope you remember. So let's add another layer of complexity to this. Okay, so now we're back to Desmos, and I want you to note now that we've added another layer of complexity to our absolute value part. So when we first started, all we had to do was graph it, right? All we had to do was look at the solutions. Here, we actually had one step to solve, right? We had to subtract 5 from both sides. Now, we don't have an absolute value part that is isolated. We're going to have to isolate it first. So here is our graph that was shifted over 5 to the left, and it's also shifted down 2. Okay? So, let's take a look at let's take a look at the solutions, and then we'll prove it with algebra. So we have negative 14, and here we have positive 4. All right? So here we go. Okay, so here we are back with pencil and paper. So here's our problem. The absolute value of x plus 5 minus 2 equals 7. Okay? So before we can break this in half, split it into 2, and solve for our positive and negative solutions, we need to isolate the absolute value part. And you can see that by adding 2 to both sides, I did that. So now I have my absolute value part isolated, the absolute value of x plus 5, and it equals 9. At this point, I can split the equation into my two solutions, positive 9 and negative 9. Okay, so here we go. X plus 5 equals 9, minus 5, minus 5. And over here, let's do the same thing. X plus 5 equals negative 9. Subtract 5, subtract 5. Okay? Okay, so let's finish this up. Negative 9 minus 5 is negative 14. I hope you remember seeing that solution, x equals negative 14. And here's our other solution. 9 minus 5 equals 4. And likewise, I hope you remember that as a solution. X is also equal to 4. All right? One more level of complexity, and then I want to show you a couple other things. Okay, so here's our last layer of complexity. So not only have we shifted our graph 5 units to the left, and not only have we shifted our graph down 2 units, but we have also stretched it by a factor of 2. Okay? And we're leaving our constant y function the same, y equals 7, and you can see that right here. So here are our distances from 0. Look at this. One of our solutions is negative 0.5, and the other one is negative 9.5. See, you can see that's what it is. Okay? So let's solve this one with algebra, and then I've got 2 other things to show you. Okay, so just like I've been saying, and I will continue to say, because repetition helps, that our goal is to isolate the absolute value portion first, and then we can split the equation into 2 and solve for our positive and negative solutions. Okay? So the first thing I'm going to do is I'm going to add 2 to both sides, just like I did the last time. I hope you remember that. So that's going to give me 2 times the absolute value of x plus 5 equals 7 plus 2 is 9. Okay? So now you can see that I have a 2 multiplying this x plus 5. Technically, you can get the same answer if you distribute the multiplication. But I'm going to ask you not to do that, because when you do that, you give yourself another step. Okay? You're just going to have to divide by 2 anyway, because you can see you're going to be multiplying 2 times x. Okay? So let's just divide by 2 straight away and just get that out of the way. Okay? So now I have the absolute value of x plus 5 equals 4.5, which is what 9/2 is. Okay, it's 4.5. So at this point, oops, I lost a side of my absolute value bar. So now we have what we need. We've got the absolute value part isolated. So now at this point, I can split these two up. I've got x plus 5 equals negative 4.5. And I have x plus 5 equals 4.5. Okay? So let's go ahead. Let's do it. Subtract 5 from both sides. You see how we end up with x equals negative 9.5, just like you saw on the graph. And here we're going to do the same thing. Subtract 5 from both sides. And I've got 4.5 minus 5. X also equals negative 0.5. Okay? So now let's look at 2 other things I want you to note. Okay? All right, guys. So now you notice that I'm still using my my stretched and shifted graph, but the constant is different now. And I want you to notice how many places the graph is touching the line. Here it's only touching in one place. It's touching at the vertex. Okay? All of our other solutions were up here in the body of the graph. Now we only have one. For the interest of time, I'm not going to show you this on pencil and paper. I'm just going to tell you, I'm going to invite you to see that when I would go to solve this, when I added 2 to both sides, I would cancel out this 2, wouldn't I? And I would end up with 0. And 0 divided by 2 is still 0. So when you end up with an absolute value part that is equal to 0, you only have one solution. And I wanted to show you that. Okay? And then last but not least, this is what no solution looks like. Okay? If I added 2 to both sides to begin the process of isolating the absolute value part, you would see that when I added 2 to this, I would still end up with negative 1. Okay? And I cannot have the absolute value part of a graph equal a negative number. It's obvious from looking at this that these two graphs will never touch. It's just like solving systems when you have parallel lines that will never touch. So this is what no solution looks like, and this is what it means. Thank you guys for listening, and we'll see you in the next video.